Hello and welcome. I'm Bill Wake. We're here this week working on an Elm interpreter. This is the third session to integer and beyond. We're going to try and get some multi-digit integers working. Unfortunately, I messed up the recording earlier, so this is kind of a reconstructed summary, quick version of it. But let's go. So we started last time working on literals, just the integers. We did a single-digit integer. We are about to do multi-digit integers, and then we'll go on and work on some floating point numbers. Along the way, we've started looking at parser combinators, abstract syntax trees, and interpreters. We've got combinators for match, many, reduce. Well, not all are combinators, but anyway, we handle single character matches, one or more of something, and reduce. I don't quite like reduce, and we're going to work on that. We're going to finish integers, do some testing. We're not going to do character view, but we will move on to float. All right, let's go. And okay, so we have Xcode. Let me go. I'm just going to kind of work my way. I'll just mark things secret for a moment. All right, here's our starting point for today. We have a parser defined. We have the match I talked about, match one character. We have a function digit I think we're going to move away from, and a many-one parser combinator. Those things help us do what we're doing. So integer tests, we parse that we can match one digit. The way this works with the combinators approach, we're going to peel off the first character to be that digit, and then X will be the rest of the text, and we give this thing a type of number. So right now our parser structure, if you give it the digit parser, let's go back. Here's the digit parser, you give it that, and you can peel off this first matching character, wrap it up in an Elm result type with the integer value and the number type for its Elm type. And we're still primitive on that. All right. So we ran this where we left off. This test was failing. We wanted to do parse multiple digits, 42 plus 12, and 4 followed by 2 we get, but 44 followed by 2 is not the same as 12. So we had some work to do. All right, on to the next version. We're looking at this thing, and we've tried to do a match a digit, many of them, and then do a reduce with 0 and this reduce Elm integer method. So reduce we added late on the day, Wednesday, I think. Let's see, down here somewhere. Yeah, so reduce, it's like reduce for a map, or reduce for a collection or stream of some sort. It takes a seed value and a combiner. So in our case, we want to add up the digits, multiply each by 10 and add them or whatever, and basically build up the value. So let's see, here's our multiplication. So reduce Elm integer we'll feed it a seed of 0 and get 10 times each digit plus the value of the next, So standard conversion. I don't particularly want to do that, but we're just trying to get through here. Okay, so let's go back to our test. All right, and this, well, I'm surprised it's disappearing, but the test was failing. We wanted to parse 42 plus 12, pull out the 42 off the front and leave the plus 12 on the back, and get a single number, 42, with Elm type number. All right. This is kind of a confusing mess right now, as far as I'm concerned. We're kind of in the midst of trying to build this thing up. So you can see we've added stuff. We had the match. Now we got a couple functions around Elm integers. We have digits that we had before. We added something to classify characters, and we had many-one. We didn't have map, and we didn't have reduce. So it's like this failing test driving a bunch of really painful stuff. Probably went too long. I don't know. It seems to be a habit on this version, but let's see how we got things going and simplified it. We have things going. It's doing the parse, but it's painful. I don't know if we can run it. Run the tests. That's the good thing of working with this sort of functional style. I don't know. You get the same thing with objects sometimes, but you can really tell when it's being too painful to get something done that you just gotta find a better way. So this passes its test. It does parse 42 for us, but I find it super clunky. So we went in and did a bunch of cleanup and refactoring and worked to simplify it. And that was the bulk of today's lesson or today's exercise. All right, now we've done a bunch of improvements. Let's see where we are. We've got this extension character. We'd pulled it out to its own class. There's some sort of Xcode bug that makes it keep finding it and not finding it. So it's here for the moment. We still got match. We've got a reduce Elm element, Elm integer that calculates still. We've got the digit. We've got many one parser and map. But I've changed from the reduce to this notion of combine. And what you can see is you get a bunch of values, and we're going to call this combiner. We're going to have a function that takes this type and combines it together. So when you call it, you're combining with characters to Elm integer. Its input is array of character, which is coming from the other parser side, and its output is AST. So AST is U here and U here. So the combine method produces a parser that produces ASTs, if I can say it that way. And this sort of two-level thing is characteristic of the way we're working here. But at any rate, the combine is much more the operation I want. I've got a string of stuff. I want to convert it into a number. That's a conceptual thing to me. The reduce felt like I was mixing levels or something. So I think this is quite an improvement, and it will get better even. But we are still passing the test. I don't know if this is just an artifact. I think. Bouncing between versions, I get a lot of that. Okay, 5 tests, 0 failures. Yeah, so we are passing our test still. Okay, but we can keep refactoring and keep improving it. So let's go on. All right, the next level was more refactoring. So we're still matching these things, but let me show you what I've pulled out. Where's the test? So what I've done is I've taken that combine expression that was kind of long, and I've pulled it into a method or a variable on parser, Elm parser. So let's find that. Okay, so integer literal says match a character that's a digit, many, one or more of these, and then combine those characters into an Elm integer. And that's exactly the parse we want. We're trying to get from chunks of the input stream into AST, abstract syntax tree. Not much of a tree yet because all it is a leaf that's the integer, but getting an Elm integer out of it is definitely an improvement. So let's just check out that type. AST has Elm integer holding the value and the type, and the type is only new number at this point. So this is perhaps a little speculative generality, but I don't feel too bad about it. Let's look at the parser. All right, so the parsers, it's still got match and it's still got many one, and I think this can be improved. We have map characters, and then we have this combined. So we've definitely trimmed it down some, and we're making good progress on that. Okay, we're one step further along. We're still pretty much the same on the parser class. We did a little bit of changing on this Elm parser, so we have the function for it pulled over here. So I'm starting to split apart. These are things that are part of the parser. These are things that are more specific to Elm. And character converting to an Elm integer is, it sounds like it is, then it is. All right. Let's see some tests. So I started making parser tests. This is for match. And we split off parser tests from integer tests, so we can match digits, don't match non-digits, watch for end of string, do actually interpret our thing. Those are all good. We've got some character category tests and this match test. I want to add tests for the other features. I'll probably do it as we go, pay as we go a little bit. The trick with this is I'm driving at a pretty high level, especially when you think about interpreter. In this case, like where's integer tests? Like here, this interpreter parse this thing. Well, parsing, I mean, ours is fairly simple at this point, but in totality, it's going to be a very large program that we're driving through from the outside, and it's very hard to know, does many one properly work, and so on with this high level view. So I'm trying to find that right balance where I verify and validate my combinators and the parser parts, but I have to also validate that I'm getting these Elm things. So what I think that's going to mean is I may use some simple ones like we did yesterday with matching a single digit, but then today I just replaced that with the full test that matches multiple digits. And I don't think we need to do a lot of check single digits and things like that. We can find the more complicated phrases that demonstrate that the Elm parsing does work for something moderately big, and not try and test every piece of the Elm parsing, but rather let the make sure the combinators work correctly and that we can see that we're using the combinator, and then that should be good enough. All right, I don't think there's anything else on this, so let's go one step forward again. All right, so here we are caught up to the current state. We have a failing test. I actually marked it X, so it's not going to run, but the test is the right test for floats, I think. We want to parse a floating point literal, and we should see it come back as an Elm float with a particular value and a particular type. It's wrong if it comes back with anything else, and the X at the end is the rest of the input. We don't want to consume the X, we just want to stop right at it or right before it. This test is okay, but it's a big step. And so what we did, let's see, it's in Elm Parser. All right, so in Elm Parser, I defined a float literal in analogous to integer literal, and it's a sequence, and maybe seek or sequence would be a better way to do it. But we're going to match one or more digits, then we're going to match a dot, just a dot, and then we're going to match one or more digits, and we're going to combine all that, which will be a sequence of an array of characters, basically, because each of these produces an array of characters. We'll combine all that into an Elm float. So here's a converter for Elm float. It's going to take a flat map of all the characters, do string to double, and then return the right type. Okay, I thought I built after I resynced, but I don't know. We do have the Elm float type. We're actually using the double representation for it, and a float type possibility. Let's see. So from the parser point of view, I used a function then. All right, and basically we haven't implemented that function yet. But then is supposed to say, do the first parser. If that works, call the second parser. If that works, keep going until you get the whole string of parsers done, and each one feeding off the rest of the input from the one previous. If any of them fail, basically if any of them fail, return nil, because you said you had to have this followed by that. So digits followed by a dot followed by a digits. And if you have digits followed by a dot not followed by a digits, it fails even though you got the first two right. So we have to sort of enforce that sequential rule on these things. And we haven't done anything except return an empty array and an empty rest of your string. Not good. I also mentioned this only parser. This thing is really just a wrapper to take a one level type into an array so we can get consistent types across these things. A little kludgy, but I don't know a better way right now. There may be one. All right. And from our point of view of testing, in parser tests, we just have a fail. So we're going to have a reminder that we're going to parse then next time, and that's where we're leaving off. So I think we'll need to parse optional values, because you can have digits dot digits and then optionally E7 and more digits, and you can have plus or minus and various things. There's some options in there, and we don't have anything that actually handles optional, 0 or 1 kind of thing. So we'll definitely need another combinator for that. And I think I'll do the same thing. The test will drive that, but we're going to pause and then go test that combinator into existence. It's a little, I don't know, it's a little funny feeling or artificial to me. Usually I try and drive right from the stuff I want to do, but I'm I don't know if it's just because I'm following a particular approach, trying to use these combinators, or if I'd be better off with some sort of intermediate inner step kind of thing. I don't know, but I do know that I want my then function to work and my many function and all these things, and testing them only through the parser is a little clunky. So I think this is the right way to go for now. So this is where we'll pick up next time. Hope you can join me. That's Tuesday, 1 to 3 p.m. Eastern, Wednesday morning, 9 to 11:30 a.m. Eastern, Eastern U.S. EST, and Thursday, 1 to 3 p.m., just like it was today. So hope you can join me. Thanks for joining.